Okay, fine. Okay, let us start this session, right? So yesterday what we saw, we designed logic gates. Just we had given a we have given a revision, right, for logic gates. Now let's see some problems, right, that you are already tested in your exam. Before that, we would like to analyze few more properties of your digital circuits. Let's see, right, one by one. And after analyzing all the basics, right, of our digital functions, let's moving on to the problems, and then we will start K-map, right? You might be heard about these things, right? The K-map, and the K-map there are some terms that is called SOP and POS, right? POS form, SOP form, right? And standard form, some people are calling it as canonical form, right? Sometimes your expressions is called canonical form, or sometimes people are calling it as what I can say normal form, normal SOP form, normal POS form, right? We should see the answer for all our queries, right? After that, we will solve problems. Okay. Now, what we are going to do? See, now we know the basics of logic gates, and we also know the basics expressions, right? Or digital systems, basically you are using alphanumerical numbers in order to represent the systems, right? So anyway, let us take the number systems, right? And let us see some of the properties of your number system. Anyway, already I had given this property, but not completely, right? Let's recapture all those things one by one, and I'm introducing some of new people, right? So the first thing is, already we saw some basic laws in our digital system. What are those? First, already we had been discussed about commutative law. We had been discussed about commutative law, right? Yes, already we had been discussed about commutative law, right? Yeah, class is going good, I think. Okay, fine. Commutative law. Now, what we saw in commutative law, right? If I'll have an expression like A and B, right, the possible combination, first I am considering A and then I am considering B, right, that it should be equal to the value of B plus A. That is simply called commutative law. Then we had been discussed about, you can also consider the product A into B, and that should be equal to what? B into A. Second, we had been discussed about associative law, right? So already we had been discussed about associative law, right? Yes. Second, we had been discussed about associative law. Now, in associative law, what we saw, suppose I have three numbers, like three possible combinations, A, B, C, three Boolean variables, right? Now, first I am adding B with the C, and then I am adding A with this resultant combination. Instead of adding like this, let me take A first, and I am just adding with B, and then I am considering C. So there is no changes in the answer, right? Either you can add in this way or you can add this way. That is called associative law. All are being associated with each other, right? So that is simply called associative law. Like you can also write, I have A with BC, right? So first in multiplication, I am just taking Boolean variable B and I am multiplying it with the C, and then I am considering A. Or you can also consider, first you can consider A, just you can multiply it with B, and then you can consider your Boolean variable C. So that is also called, this is also associative law only, right? Next, let's discuss about distribution law, right? So now we should talk about distribution law. Let us discuss about distribution law. Now, when we are looking for distribution, what do you mean by distribution? It's very simple, right? Distribution law in the sense, for an example, listen guys, I have a function A, right? And there are few more functions, right? B plus C, right? I found there is a term that is called A, and with this we are expressing B plus C, right? Now, this expression can also be distributed, right? How it can be distributed? It can be written like this: A into B plus a into c. Just you can open the bracket and you can pass this boolean variable inside the function such that b is directly being multiplied with the a and c also going to be multiplied with the a. So this expression can also be written in this way, that is called distribution law. Like you can also consider some other variable. For an example, I have a plus b and I have c plus d. Right, instead of writing like this, you can also write, just to open up the brackets, you can write the variables like this, like a into c plus a into d plus b into c plus b into d. You can also write like this. So that is called distribution law. Simply we are calling it as distribution law, right? Next we should talk about distribution theorem, right? So there are no big difference, right? So this is distribution law. Let me introduce the next person, that is called distribution theorem, right? So let me call this one as distribution theorem, right? Now according to distribution theorem, right, according to distribution theorem, if I have a function like this, a plus b dot c, right, a plus b dot c, see, this is a dot b plus c, this is distribution law, same as, right? This is also called distribution theorem only, right? But here just opposite to this one, right? So this function can be written as, right, that is a plus b dot c can be rewritten as a plus b dot a plus c, right? A plus b dot a plus c, right? Now in opposite to this one is called transposition theorem. Opposite to this one is called transposition theorem, right? Now what do we mean by transposition theorem? According to transposition theorem, if I have a function a plus b into a plus c, that function can be rewritten as a plus b dot c. Just opposite to distribution theorem is simply going to be our transposition theorem, right? So next we should learn few more things. Let me rub this one. So the next law that we are going to discuss now is called consensus theorem, right? That is consensus theorem, right? Now what we are going to learn in consensus theorem, that's pretty simple and it's quite interesting too, and it's very important too, because while solving the problems, this theorem, it's often helping us to reduce the Boolean expressions. So keep attention with this theorem, right? So let me write the theorem first. So according to consensus theorem, if I'll find any variable like this, how, see, if a variable is like this, a dot b plus a bar dot c plus b into c. If you find any variables like this, see, let me write the expression like this. Just let me reduce this one. See there, guys. Now I'm just considering AB. I don't know the resultant expression. I'm just proving it, right? So AB, A bar C plus BC. See there, with BC, I don't have any terms, right? So let me introduce a term is called 1. Do you agree? With BC, I have 1. Correct? அங்கே 1 இருக்குன்றதை நீங்கள் ஒத்துக்கிறீங்களா? எஸ். இப்போ நான் அந்த 1க்கு பதிலாக என்ன இன்ஜெக்ட் பண்ணுறேன் அப்படின்னா, ஐம் ஜஸ்ட் இன்ஜெக்டிங் a plus a bar. I know, sorry, we all of us know a plus a bar equal to what? 1. That properties already I had given. Please revise your notes. So a plus a bar equal to 1. So similarly, you can consider b plus b bar, c plus c bar, whichever the things that you want, you can consider. For me, myself, I would like to consider a plus a bar for some reasons, right? Let's see why I am considering a plus a bar. Quickly you will come to know. So that is AB, A bar C, just open up the brackets, it is going to be ABC plus A bar BC, absolutely, right? Now from this, let us try to reduce this expression further. Guys, just consider these two people. From this, take AB outside. If you take AB outside, then you will get 1 plus C. Plus similarly, take these two expressions, take A bar C outside, then you will get 1 plus B outside, right? Now we all of us know what is the equivalent value of 1 plus C, right? Anything plus 1 will always be equal to 1 in digital, already we saw, right? Anything, you can consider A plus B plus C plus D plus C plus F plus G plus 1 should be equal to 1 only, right? So anything plus 1 in digital always equal to 1 only, such that 1 plus C also equal to 1, 1 plus B also equal to 1. So it can be further written as A plus B plus A bar C. What is the conclusion here? So the conclusion is A dot B plus A bar C. Did you notice this expression? See there, I have three variables totally, A, B, C. Totally we have three variables in the given function. Whereas in these three variables, one variable is being complemented. Guys, carefully notice this theorem. Totally in this variable, while applying consensus theorem, you should check you have to check the function properly. At least there will be three variables, right? Anyway, in your examinations and all, you will be tested with the three variables only. You will have three variables. In the three variables, one variable will be complemented. Yes, one variable will be complemented, right? With the combination of one variable, actually each and every term will be repeated twice, right? Rendu time வந்து repeat ஆயிருக்கும். Like A பாருங்க, A will be repeated twice but with a complement, and B will be repeated, C also will be repeated, right? So first thing, all variables, three variables, you will have three variables in consensus theorem. While applying consensus theorem, you will have three variables, and the second thing is, in the three variables, all the variables are being repeated, right? And the third condition, if you notice this thing, only one variable will be complemented, right? Now your target is just to keep your attention with the complemented variable. And the complemented variable க்கு பக்கத்துல இருக்க ரெண்டு பேர் அப்சர்வ் பண்ணி பாருங்க. A is being complemented here. With this I have BC. இப்போ BC இங்க இருக்க அந்த ப்ராடக்ட் இந்த BC தான் இங்க third termல வந்து மல்டிப்ளை இருக்கும். So this term is called redundant term according to the proof. What do I mean here? See there, A dot B plus A bar C is equal to, sorry, in the total term should be equal to what? I got AB plus A bar C. It means this term is missing now. The thing is, the conclusion is, in the total term la namakku output la kedaikra expression o idhula namakku kedaikra output la, right, in the term la output la kedaikra expression same da. Are you getting my? I'm repeating once again. If I'll consider any logic system, if I'll have a digital system, in the digital system, when I'm giving wiring, neenga gates on the logic gates ku vandu wiring kodutittu irukumbodho unnecessarily you no need to consider this term. If you find any terms like this with this combination, you can just neglect them, and the term is simply called redundant term. Why? Because see, according to the proof, this function should be equal to this function. So without keeping this function, directly I can obtain the result. In the total function la எனக்கு கிடைக்கிற ரிசல்ட் நான் இத வச்சே எடுத்துப்பேன் அப்படினு சொல்றேன். So it means this term is called redundant term. This term is called redundant term. So such type of this term is does not required. So you can remove it, and simply you can write this whole expression should be equal to, right? So let me write here. So AB plus A bar B, sorry, A bar C. A bar C plus BC should be equal to AB plus A bar C, right? That is called consensus theorem, right? Is it visible to you all? Yes, that is visible. Good. Fine. Let's continue, right? So let me take one more example for this. Guys, please don't forget, this is very important theorem, right? I had given the proof, right? We can also write one more way, right? So this is one way of expressing these things. Now observe. Let me write few more example for your better understanding, right? For an example, I have a function like this, like given it is AB plus B into C bar plus A into C, which is equal to what? Which is equal to what? It is equal to, let me say, if you notice these things carefully, I have a complemented term where C and C bar is being complemented each other. Exactly. With this, the product of A and B is being expressed here. We all know we can apply the same consensus theorem. According to consensus theorem, this is called a redundant term. So this expression can be directly equal to, we can write like this, AC plus BC bar. And you can neglect this term, that is called redundant term. You don't need to consider that one unnecessarily. Clear? And similarly, suppose if I have an expression like this, A bar plus B, A plus C, B plus C, which is equal to what? Which is equal to what? Notice these things carefully. Once again, in the given expression, we have three variables. Exactly, we have three variables. And the second thing is, though I have three variables, if I notice this expression carefully, I have A bar plus B, I have A plus B. See there, one person is being complemented each other. Yes, right? I have a complemented person here. With that, I am having two variables, B and C. So the third person is going to be that is advanced version of this B and C. Anyway, this is going to be our redundant term. Yes or no? According to consensus theorem, this is redundant term because this whole expression, in the whole expression la vechi neenga enna function velila kondu varinglo, same function I can express without this term, right? That is the proof for that, right? So which is equal to, right? So this function should be equal to A bar plus B into A plus C. Clear? So that is called consensus theorem. I hope things are clear to you all, right? So let us discuss about the next person, that is called duality theorem, right? So next we are going to discuss about duality theorem, right? So let me rub this one. some of the basics should be required, that's all, right? Once you get the basics, then automatically you can play with the circuits, because digital is the easiest subject. There are no things to study, right? Once you understand, you can play with the question. Let me prove it. While solving the problems, you will come to know. I don't need to prove. So next we are going to discuss about duality theorem, right? So the next theorem that we are going to discuss now is called duality theorem, right? I think this is visible to you all, right? Yeah, I hope. If it is not visible, please post it in the comment section, right? I'm watching you. According to duality theorem, right, guys, listen, what do you mean by duality, right? Now the thing is, according to duality theorem, if I'll have an expression like this, a function is being, right, a function is defined as a comma b comma c. It means I'm just considering a function in terms of ABC. ABC are called independent variables, right? So let me define. I have a certain system like this, like I have AB plus a bar c. There is a term like this. Now I would like to apply duality for this function. Now what do we mean by duality, right? Let's see what happened. According to duality, right, according to duality, and will become R. According to duality, and will become R, and R will become and. Guys, listen, most of the people of you are having a big confusion here. The thing is, உங்களுக்கு என்ன கன்ஃபியூஷன் அப்படின்னா, நான் வந்து சொல்லியிருந்தேன் இல்லையா, இந்த அண்ட் அப்படிங்கிறது மல்டிப்ளிகேஷன், ஆர் அப்படிங்கிறது அடிஷன் அப்படின்னு நான் சொல்லியிருந்தேன். சரி, திஸ் இஸ் நாட் நார்மல் மல்டிப்ளிகேஷன் அண்ட் நார்மல் அடிஷன். இப்போ நம்ம பேசிக்காக வந்து forget about the digital system. நம்ம டிஜிட்டல் இல்லாமல் ஜெனரலாக மல்டிப்ளிகேஷன் பண்ணுவோம் இல்லையா, ஐ எம் நாட் டாக்கிங் அபவுட் தட் மல்டிப்ளிகேஷன். ஐ எம் டாக்கிங் அபவுட் லாஜிக்கலி, ரைட்? இன் லாஜிக் கேட்ஸ் we have a certain set of combinations that is called and or operation. அந்த இடத்துல அண்டுங்கிறது மல்டிப்ளிகேஷனை ரெப்ரசென்ட் பண்ணுது, ஆறுங்கிறது அடிஷனை ரெப்ரசென்ட் பண்ணுது. பட் தட் லாஜிக் இஸ் நாட், இட் இஸ் நாட் லைக் 1 + 1 2, 2 + 3 5 அப்படின்றது நம்ம நார்மல் இதில் போடுவோம் இல்லையா, இங்கே அப்படி கிடையாது. சி, ஆர் கேட்டில் நம்ம என்ன பண்ணுவோம், 1 1 ரெண்டுமே 1 1 வந்து அவுட்புட் இஸ் கோயிங் டு பி 1. we are not putting any 0 or any other. that is not addition. we are not performing addition. ஆர் கேட்டை பொறுத்த வரைக்கும் என்ன அப்படின்னா, if one pin is enabled, output will be enabled. and கேட்டை பொறுத்த வரைக்கும், if one pin will be disabled, output will be disabled, right? So based on that functions, we are performing some and that is multiplication and addition operations. Don't compare this logic with your normal addition and normal multiplication. That is wrong actually. Okay, fine, let's continue the operation anyway. According to duality, so just apply. This is the operation now. Now and means what? See there, here we have and a dot b. So here we have and multiplication. A dot c, here we have and, here we have this function had been added up with this function, that is called addition, right? So we have three people here, multiplication, addition, multiplication. Now just apply duality. According to duality, this function should be, right? So இப்போ இதுக்கு நீங்க duality apply பண்ணீங்கன்னா, this function can be written as duality of this function is a, right? Again dot will become what? Plus. Why? Because and will be transformed as r will be transformed as and, such that dot will become addition. Dot வந்தது அப்படின்னா அது r ஆ மாறும், right? So a plus b, right? I'm just closing it, and plus will become dot. I'm putting dot, and a bar dot will become plus. That's all. That is called duality. That is called duality, right? Now see there, now if I am taking one more duality for this, if you are taking again duality for this function, then what will you get? If I will take duality for this function, again plus will become dot will become plus, you are getting original function. So in order to obtain the original function, right, in order to obtain the original function, right, you will have to take 2 times duality. If you take 2 times duality for any function, then that function again regains its original property, right? ஒரு ஃபங்க்ஷனுக்கு வந்து நீங்க 2 times duality எடுத்தீங்க அப்படின்னா again you are getting back to the original function. Clear? Yes. So that is called duality theorem. I hope things are very clear to you all, right? And there is one more term. There is some functions, right? ஒரு சில ஃபங்க்ஷன்ஸ்லாம் இருக்கு, அந்த ஃபங்க்ஷனுக்கு வந்து நீங்க duality எடுத்தாலும் again you are getting the same function, right? There are some certain functions will be there, right? So if the conclusion is, right, we are going to discuss about self-dual expression, right? So self-dual, what do you mean by self-dual? Self-dual means நீங்க duality எடுத்தாலும் ஆல்ரெடி என்ன ஃபங்க்ஷன் இருக்கோ அதே ஃபங்க்ஷன் திரும்ப எக்ஸ்பிரஸ் ஆச்சு அப்படின்னா, that is called what? Self-dual, right? So for an example, if I'll have a variable a, if you take duality, then what you'll get? Duality of a is a only, right? Suppose if I have what let me express, right? Let me consider one more variable, b bar, right? let us have having V bar, right? If I take self dual, then B bar self dual will become V bar only. You see, do you have any dots or cross here? No. Such that you'll have some other examples. The example is self dual means, right, or function க்கு நீங்க dual எடுத்தாலும் again you are getting the same function, then that is called self dual, right? So the thing is self dual expressions, right? So the number of maximum number of possible, that is maximum possible self dual expressions for a given variable, right? So for an example, let's see self dual expression, guys listen, self dual expression, let me keep like this, the maximum possible self dual expression for n variable. ஒரு n variables வந்து கொடுத்துருக்காங்க, அந்த variables n variable அப்படின்னா like you are considering a b c d e f g h, like that you are considering n number of variables, right? So while considering n number of variables, what are the maximum possibility of self dual expressions, right? கேட்டாங்க அப்படின்னா just the possibility is, that is observation, right? So that is called 2 power n minus 1, 2 power n minus 1. Now for an example, right, I have a 3 variable boolean expression, right? So 3 variable, for a 3 variable logical expression, right, how many possible, what is the maximum possibility of self dual expression, right? But 3 variables setting அப்படினா n denotes 3, right? So now the possibility of self dual expression is going to be, that is 2 power n is replaced by 3 such that 3 minus 1 will become 2, so 2 power 2. See there, 2 square will be 4, so it can be written as 2 power 4, which is equal to 16. So what is the conclusion here? For a 3 variables, right, இப்போ நீங்க 3 variables consider பண்றீங்க, a b c அப்படினு சொல்லிட்டு 3 boolean variables consider பண்றீங்க அப்படினா அந்த 3 boolean variablesல you can bring to, that is 16 possible combinations of self dual expressions. Clear? Just do remember this formula because you will be often tested, right? So you will be often tested in an examination. Clear? So that is how we are obtaining self dual expression, right? Now coming back to the conclusion, one more important thing that you all have to observe. Listen guys, நம்ம இந்த digital systemல பொறுத்த வரைக்கும், right, some things we are directly writing, right? One thing you all have to understand, நம்ம digital பண்றது எல்லாமே என்னன்னா, we are simply calling it as postulates அப்படினு சொல்லுவாங்க. What do you mean by postulates? Postulates அப்படினா ஒரு சில விஷயங்கள் வந்து எப்படி நடக்குது அப்படிங்கிறது நமக்கு தெரியாது, but it's happening. Do you know how this universe will exist? That is, it was exist, right? In the universe வந்து எப்படி exist ஆச்சு அப்படிங்கிறது நம்ம யாருக்குனா question தெரியுமா? No, but we are living here and we are just going, right? நம்ம அதை பத்தி research பண்ணிட்டு இருந்தாலும் okay, something is happening. We also know நம்ம எர்த்தை சுத்தி வந்து magnetic field exist ஆயிருக்கு அப்படிங்கிறது. Do anyone, right, does anyone know the reason for this? ஏன் வந்து இந்த மாதிரி ஒரு ஃபீல்ட் இல்லை எப்படி எக்ஸிஸ்ட் ஆச்சுன்றது தெரியுமா? நோ, ஜஸ்ட் இட் இஸ் எக்ஸிஸ்டிங், ஜஸ்ட் வி ஆர் ஃபாலோவிங் அண்ட் வி ஆர் யூசிங் இட், ரைட்? ஸோ சேட்டலைட் வந்து நம்ம எக்ஸாக்டாக ஒரு பொசிஷன் வந்து ஃபிக்ஸ் பண்ணுவாங்க ஜஸ்ட் வித் தி ஹெல்ப் ஆஃப் கிராவிடேஷன் பொசிஷன், தட் இஸ் கிராவிடேஷனோட ஃபோர்ஸ் வந்து கரெக்டாக எந்த இடத்துல யூக்லிபிரியம் பாயிண்ட் வருதோ அட் தட் பாயிண்ட் வி ஆர் ஃபிக்ஸிங் சேட்டலைட். ஸோ கமிங் பேக், தி கன்க்ளூஷன் என்ன அப்படின்னா, டிஜிட்டல் சிஸ்டம் பொறுத்த வரைக்கும் நிறைய கன்க்ளூஷன்ஸ் அங்கங்கே கொடுத்துருப்பாங்க, விச் இஸ் ஈக்குவல் டு திஸ் ஒன், திஸ் இஸ் ஈக்குவல் டு திஸ் ஒன். அப்படின்னா மீனிங் என்ன அப்படின்னா, இந்த மாதிரி ஒரு லாஜிக்கை நான் கொடுக்கும்போது அந்த மாதிரி நடக்குது, எப்படி வந்துச்சு தெரியல, பட் இட்ஸ் ஹேப்பனிங். பட் அதனால எனக்கு அட்வான்டேஜ் வருது, இந்த மாதிரி நடந்தால் ஐ எம் ஃபீலிங் ஹாப்பி. ஒரு விஷயம் வந்து சுவிட்சை போட்டால் பல்ப் எரியுது, ஐ எம் ஃபீலிங் வெரி ஹாப்பி. வீடு வந்து என்ன ஆகுது, நல்லா பிரைட் ஆகுது, தட் இஸ் வாட் ஐ வாண்ட். பட் எப்படி எரியுது, ஐ டோன்ட் நோ தி ஆன்சர் ஃபார் தட் கொஸ்டின். ஓகே, ஆன்சர் தெரியாட்டி என்ன, நமக்கு தேவை பிரைட்னஸ், அது கிடைச்சிருச்சு இல்லை, ஜஸ்ட் வி ஆர் கோபிங், ரைட்? ஸோ தட் இஸ் கால்ட் postulates. ஸோ இன் டிஜிட்டல் மோஸ்ட்லி, ரைட், ஸோ வி ஆர் sometimes, that is people are calling it as, that is postulates. Postulates in the sense, some things will be given like this, something just we are following, yes it's happening, just taking and just proceed. Go ahead, right? Go ahead with this. That's all, right? So that is called postulates. Let's continue. ஸோ அப்போ நம்ம அங்கங்கே ஒரு சில விஷயங்கள்லாம் நான் அப்படி ப்ரூவ் பண்ணியிருப்போம், அப்படியே எடுத்துக்கோங்க, இப்படி எடுத்துக்கோங்க அப்படின்னா இட் மீன்ஸ் இப்படி நீங்கள் எடுத்துக்கலாம், எப்படி வந்துச்சு தெரியாது, ஜஸ்ட் எடுத்துக்கோங்க, அவ்வளோதான், தட்ஸ் ஆல், ரைட்? ஃபைன். Let's continue. So this is called duality theorem, right? Now we should talk about complementary functions, right? Next theorem is complementary theorem, right? So the next theorem that we are going to discuss now is called complementary theorem, right? Complementary theorem. Now what do we mean by complementary theorem? Let's see. Complementary theorem in the sense, right, just we have to consider, guys, let us consider I have a certain variable like a comma b comma c. Once again, it is being defined as a bar bc plus, let's consider a bar b bar c, right? I have a certain variable like this, right? Now the question is, you are requested to find out the complementary of this function. Complementary in the sense, first step number 1, right? R will become R will become and will become R. It is same as our duality, right? And will become R will become and. First we should apply duality. With this, as well as the second step, right? A will become like general. Let me generalize. We should take complementary for all variables, all literals. Let me simply call literals. Literals in the sense, each and every Boolean variable are called literals, right? How many literals are there? Literal 1, literal 2, literal 3, literal 4, literal 5, literal 6. Totally I have 6 literals, right? So we should take a complementary for, that is complement for each and every literal, right? So complement, right? We should take complement, right, for every literal, right? So just we should take complementary for every literals, right? Fine. So each and every term is called literal, right? For each and every literal we should take complement. So let's continue. Let's apply what I can say, complementary theorem. According to complementary theorem, complementary of the given function is going to be first a bar. If you take double bar, right, according to involution theorem, right, so that is called involution theorem. Anyway, the theorem is not required. We all know a double bar should be equal to what? A, right? That is called what? Involution theorem. That is called involution theorem, right? If I'll have a, I'm just taking complementary, I'm getting a bar. If you take again bar for this one, then you are getting a double bar, which is equal to what? A only. That is called what? Involution theorem. That is called what? Involution theorem. That is called involution theorem. According to involution theorem, if you take double bar for any function, then you will get original function. If you take 2 times complementary for any function, then you'll get what? Original function, right? Like our duality. So what is the conclusion here? The thing is, let us apply this one. If I'll take complement for a bar, you are getting a double bar, that is equal to a only. And then see there, here we have dot. Dot means under. We should transform it into R. R means addition. First. Next I have B. B will become B bar. Then here B dot C. Dot will become plus and C will become C bar. Let us close, and here we have addition, that will be transformed to dot, right? Next a bar will become a double bar, such that it will become a, and dot will be transformed into addition, right? Again B bar will become B double bar, which is equal to B, and then dot will become plus and C will become C bar. Clear? So that is called complementary theorem. That is complementary theorem. Just remember this one, right? So these properties are very important, right? So these properties are very, very important. So let me rub these things first. Okay. Now one more important thing is there, right? That is observation only. That is, for an example, for n variable, right? For n Boolean variable, right? We have to see, right? We have to check the number of possible combinations, as well as we should check the maximum number of possible expression of functions, number of possible functions in the output side. Let us check these two things for n Boolean variable system, right? In order to get the better idea for this, let us take one variable, right? Let me select a variable a, right? In binary, if I'll select a variable a, right, that variable might be 0 or 1, we all know, right? So from the input side, I am giving a equal to 0 and a equal to 1 for these two set of possibilities, right? So see there, they are called combinations, right? So that is called combination. For one variable, there are two combinations could be possible. Either you can write this one as 0 or you can write 1. 0 nil or 1 nil. It means a might be 0 or a might be 1. So there are two possible combinations, right? What about the correspondent functions? The correspondent possible functions are, let me write, its correspondent output. While giving 0, your output might be 0 or your output might be 1. There are two possibilities. Let us see. While giving 0, while if you 0 கொடுக்கும்போது output might be 0 and நீங்க 1 கொடுக்கும்போது output might be 0 வந்திருக்கலாம். There are two possibility, right? Second case, F2, right? F2, right? While giving 0, right? output might be 0 and while giving 1, output might be 1. Second possibility, right? So the third function, while giving 0, output might be 1, right? So this might be 0. Fourth possibility, while giving 0, this might be 1, this one also might be 1. So we have seen there are four possible functions. Do you have any other expressions, other possibilities? No, it is not possible. If you have two variables, two binary variables, then the four combinations could be possible. Four functions could be expressed, either 0 0 0 1 1 0 1 1. That is the maximum possibilities. So what is the conclusion? What we have understood here, if you have a single variable, then we have two possible combinations under four possible functions. Yes, that is correct. Let us extend our discussion. Let me consider two variables now, right? So let us increase our discussion, that is extend our discussion. Let us consider two variables, a and b, right? If I have a b 0 0 0 1 1 0 1 1, there are four possible combinations, right? Its correspondent function, first one, there might be the correspondent functions are all might be 0, right? For 0 0 you might be get 0, for 0 1 also you are getting 0, for 1 0 also you are getting 0, for 1 1 also you are getting 0. Other possibility where an output or long you may get 0 0 0 1, or the next possibility, just to extend this discussion. Of course I know you all are getting the idea now. Just to see there, இப்போ இந்த மாதிரி எத்தனை possibility வரலாங்க? Since we are considering two variables, here we got four possible combinations. For four possible combinations, we can express 16 possible functions. Do you all agree with me? 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 1 0 1 double 0 0 1 0 1 0, that is 0 1 0 1. So let's see. இப்போ இந்த மாதிரி possibility அடுத்து நீங்க என்ன எழுதுவீங்க? F4 can be written as 0 0 1 1. Next F5 can be written as 0 1 double 0, then 0 1 0 1, and then 0 1 1 0, and then 0 triple 1, and then 1 triple 0, 1 double 0 1 1 0 1 0 1 0 1 1. Like that we can express 16 combinations, right? So these expressions can be continuous up to 16th possible. All the outputs are going to be expressed as 1, such that how many possible combinations we got here? Output functions, right? So the possible functions are 16, whereas possible combinations are 4 for two variables. So what will be the conclusion here? Did you notice these things carefully? Guys, listen. So the conclusion is, for n variable, the number of possible combinations are 2 power n. For the number of possible functions are 2 power n. Am I correct? Check பண்ணிக்கலாமா? Yes. So when I was considering n equal to 1, n equal to 1 ன்னு consider பண்ணீங்க அப்படின்னா, your output possible variables are n equal to 1 அப்படின்னா we are considering only one variable. Its correspondent possible combinations are either it might be 0 or it might be 1. What about the number of possible functions? Functions are Boolean expressions, right? So some people are calling it as Boolean expression. The possible Boolean expressions are, the possible Boolean expressions are, we can express four possible way. நம்ம எத்தனை way பார்த்தோம்? Four possible way. அப்படினா என்னங்க? See there, can I write like this? இங்க n க்கு 1 போடுங்க, 2 power 2 will become 4 only. Yes, I am correct. Similarly, if I am putting n equal to 2, இப்போ n equal to 2 போட்டீங்கன்னா 2 power 2 will become 4. Yes, we got four possible combinations, right? இங்க நீங்க 2 க்கு இங்க n க்கு 2 போடுங்க, 2 power 2 will become 4. 4 power 4 will be 16. Yes, I got 16 possible combinations. So what is the conclusion here? So the maximum number of possible combinations or Boolean expressions for n Boolean variable system is 2 power n, whereas the number of possible, this is number of possible functions or Boolean expressions, this is number of possible combinations that we can express, that is simply called 2 power n. Don't forget this one, because you will be tested for some worthless one more question. If you remember this one, simply you can give the answer. Okay, fine. So let me rub this one. I think class is going good. Yeah. Okay, fine. Now let us see the difference between normal form and standard form. Standard form, some people are calling it as canonical form, right? So let us see the normal form, normal representation versus canonical or standard representation, right? So what is the difference between normal and canonical representation? Let us see the difference between normal representation and canonical representation. Canonical, that's pretty simple. The thing is, for an example, I have a variable here that will be defined like this: AB plus A bar BC, right? I have a variable like this. Now let me consider one more variable here, like AB C bar plus A bar BC. Now, what is the difference between these two, right? If you notice these things carefully, actually here we have three variable system. இதை நம்ம கேர்ஃபுல்லாக அப்சர்வ் பண்ணி பார்த்தா இங்கே எனக்கு என்ன தெரியுது அப்படின்னா, இது வந்து த்ரீ வேரியபிள் சிஸ்டம். த்ரீ வேரியபிள்ஸ்னா ஏபிசி. ஆனால் இதில் ஒரு டேர்ம் வந்து ஏபிசி கரெக்டாக எக்ஸ்பிரஸ் ஆயிருக்கு, ரைட்? ஸோ ஆல் லிட்ரல்ஸ் ஆர் பீயிங் எக்ஸ்பிரஸ்டு ஹியர். இங்கே existing, all literals are existing here, but here one literal is missing. That is called a normal form. But if you notice this one, see there three variables, right? All are first term in three literals irukku, second term in three literals irukku. That is called a standard or canonical form. So if you find any missing term, then that is called a normal form, right? If there is no any missing terms, each and every terms are being expressed perfectly, right? If a three variable system na over term la ethana irukanum, right? In each and every combination we will have what? Three variables irukanum. If you find ipo enakku system வந்து three variables but ஒண்ணுத்துல three variables இருக்கு, இன்னொன்னுத்துல three variable இல்ல அப்படினா, so that is called what? That is normal form, right? So in order to convert this one into standard form or canonical form, what we need to do? For an example, sir, okay, this is normal form, I understood. This is called canonical form, I also, right? This one also I understood. Let me take one more example first. One example, I have ABC bar plus A bar C bar. It is being expressed like this. Whereas here I have a function A bar BC B bar C bar A plus A bar B bar C bar. A function is given like this. What is the difference between this? Again, this is also called a three variable system, but if you notice the second expression, one term is missing. A is there, C is there, but B is missing. But here I have three set of terms, right? But all are what? All are what? All are having proper literals. ABC will be available, ABC will be available, ABC will be available. That is called canonical or standard form. This is called what? Normal form, right? Some term is missing here, right? Fine. Suppose if I'll find any term like this, how do I get the canonical form from this one, right? So that is the conversion, right? So that is the conversion from normal to canonical form, right? So conversion of a normal expression to canonical, right? So conversion of normal to canonical. What we need to do? Very simple, guys, listen. Let me take these two. For first example எடுத்துக்கலாமா? Actually I have AB, but இங்க என்னது missing? C is missing. But we all know with this AB we have 1. Do you all agree with me? Yes. 1 க்கு பதிலா நம்ம என்னங்க replace பண்ணலாம்? எந்த term miss ஆயிருக்கு? C, right? அப்ப C in terms of C ல 1 can be written as C plus C bar. Do you all agree with me? Yes. Plus A bar BC. That is called standard canonical form, right? So if you open up the bracket, it is going to be ABC plus ABC bar plus A bar BC. Do you have any missing term now? No. See there, I have three literals, three literals, three literals. Happily you can write, right? So that is called what? Normal to canonical form. Similarly, let me write the expression for the second person also. Which is the missing term here? Let me write. First one is ABC bar, there is no problem. Whereas in the second term, A bar is there, C bar is there, but B is missing, right? Anyway, we all know that is there we have 1. That 1 can be replaced by B plus B bar. Yes. If you open up the bracket, it is going to be what? A B C bar plus A bar C bar B plus A bar C bar B bar. Clear? That is standard form, right? So this is how we are transforming a variable from normal to standard. Clear? Yes. Let us take some more examples. There is few more example for this. Let me rub this one. Yeah, example number 3. Let us consider a function had been expressed as a comma b comma c, right? It was being expressed as a bar plus b, and we have a plus b plus c bar, right? Now what the hell it is happening here? The thing is, see there, it is in the another form, right? I know, see, this is called, if you want to know this one, this is called product as a, yeah, this is called sum of product and this is called product of sum, right? See, let me write, I will explain all those things soon. What is the difference between sum of product and product of sum? Sum of product in the sense, see there, sum of product அப்படினா ப்ராடக்ட்ல இருக்க டேர்ம்ஸ் வந்து அடிஷனல் இருக்கும், right? What do I mean? Sum of product in the sense, first we should multiply. See there, these three variables are being multiplied each other. These two variable is multiplied each other such that sum of products is called sum of product. See there, sum of products, right? Again, sum of products, sum of products, sum of products, sum of products, sum of products. Do you all agree with me? Yes. இப்போ இதை கவனிச்சு பாருங்க. I have two set of variables. அதுக்குள்ள பாத்தீங்க அப்படின்னா sum இருக்கு and then we are using multiply them, right? So that these two set of functions are being multiplied each other. That is called product of sum. That is called product of sum, right? Yeah. Soon we will discuss about those people, right? Because you might be wondered, that's why I'm giving introduction. We will see that is very simple only. Soon we will see that things also. So anyway, this is product of some form, right? Yes. So but the problem is what is the missing term here? Here the missing term is, in this case I have a bar plus b, but here I have a plus b plus c, right? So the thing is, three literals are being expressed here. We have only one literal here. So what I have to do, shall I write this function like this, a bar plus b plus 0, right? Yes, we can write like this, and here this function can be written as a plus b plus c bar. Let us write, right? Let us extend our discussion. A bar plus b plus 0 can be replaced by, which is the missing term here? Actually a is available, b is available. The missing term is c. அப்ப c க்கு பதிலா நான் என்ன எழுதுறேன்னா, அந்த 0 க்கு பதிலா let me write c dot c bar. Any mistake? Guys, listen. We all know some of the postulates already we saw. A plus a bar will always be equal to 1, right? And similarly, a dot a bar will always be equal to 0. You can consider b plus b bar, c plus c bar, whichever the things that you want. Generally, I am saying like this, right? So like that, I have 0 here. I don't have any variable. I am just considering 0. For 0, we can consider c dot z bar. Just this operation will be opposite to this one. இங்க நம்ம 1 கன்சிடர் பண்ணிருப்போம், இங்க நம்ம 0 கன்சிடர் பண்றோம். இங்க இது அடிஷன்ல இருக்கும், இங்க ப்ராடக்ட்ல இருந்து இருக்கும். கரெக்ட்டா? இங்க பாருங்க, we are considering multiplied values, here we are considering additionally. Just opposite, that is product of sum and sum of product are always what I can say complement of each other. We will see soon. I will explain all those things, right? Anyway, let me demonstrate before that. So let us consider this one also, a plus b plus c bar. Let's see what happened now, right? Let us apply distribution theorem, right? According to distribution theorem, right? So what do we know according to distribution theorem? Let me rub these things because I don't have space. Yeah, let's see now. According to distribution theorem, right, what we know, a plus b dot c, right, it can be expressed as, idu nam eppadi eludikalam, it can be written as a plus b into a plus c. That is the postulate that we had been observed from distribution theorem. Exactly, that is correct. Now let me treat this whole variable as x. Let me just replace it by x in order to get the clear idea. அப்ப இங்க என்ன இருக்கு, I have x plus c dot c bar. அப்ப இது எப்படி எழுதுவீங்க, it can be written as x plus c, right, dot x plus c bar, right? And then you can consider this one, a plus b plus c bar. Let us substitute. X க்கு பதிலா என்ன substitute பண்ணிக்கலாம், because you might be confused, that's why I am just considering a single variable. X is nothing but a bar plus b plus c. Now you can write like this, x is nothing but a bar plus b. Now you can consider c bar, right? And then we can write a plus b plus c bar. That is the standard representation or canonical form. Clear? I hope things are clear to you all. Let me take one more example for your understanding. Yeah. Let us consider f of a comma b comma c, which is equal to, right? So let me consider some functions. Let us consider, what shall we do, a bar plus b bar, right? And let me consider b bar plus c bar, right? Okay, is this function is completed rightfully? No. If you notice this one, I understood one thing. இந்த ரெண்டு ஃபங்க்ஷனையும் தனித்தனியாக பார்க்கும்போது இங்கே பார்த்தா ஏபி இருக்குது, இங்கே பிசி இருக்குது. ஸோ கண்டிப்பாக இதில் 3 வேரியபிள்ஸ் இருக்குது. ஏன்னா ஏ இருக்குது, பி இருக்குது, சி இருக்குது. பட் இந்த ஃபர்ஸ்ட் செட் ஆஃப் ஃபங்க்ஷனில் சி இஸ் மிஸ்ஸிங். செகண்ட் செட் ஆஃப் ஃபங்க்ஷனில் ஏ இஸ் மிஸ்ஸிங். ஸோ இஃப் யூ வாண்ட் டு transform it into a standard or canonical form, what the hell we have to do? There are nothing, right? This thing is very simple. What we need to do? A bar plus b plus 0 we have to consider. Similarly, b bar plus c bar plus 0. Exactly. Next, a bar plus b plus 0. Which term is missing? C. So here we have to consider c dot c bar, right? Plus b bar c bar plus 0 is 0 can be replaced by what? A dot a bar. Yes. Now let us continue. Now we all know, once again, treat this whole variable as x for a better understanding, right? So then what will happen? X plus c. அப்போ இது எப்படி எழுதிக்கலாம் direct? Now you know, right? You might understood. Let me write the answer directly. So it can be written as a bar plus b plus c bar. Similarly, this can be, shall we rub this one? So it can be written as b bar plus c bar plus a, right? And second term will become b bar plus c bar plus a bar. This is the complete canonical form, right? Feeling happy? Is there any missing term now? No. We got the full expression, right? So that is how we are writing the expression in standard or canonical form from normal POS or SOP form, right? So இப்போ நம்ம பார்த்தது என்னன்னா, that is SOP form and POS form only. This is called what? Product of sum, right? Am I correct? Just observe. See there, here we have a product, that is here two variables. Inga additional irukku, inga additional irukku, that is product of sum, right? Again we can say that is product of sum. Again we can say product of sum. Am I correct? Yes. So that is called POS form. This is called POS. See there, product of sum. Clear? There is one more form already we saw, that is called what? Sum of product, right? Yes. Now let me rub this one. Okay, so your basics are over, right? Next, actually we need to talk about min terms, max terms. That is product of sum and sum of product only, and then immediately I have to talk about K-map. So I don't want to go with that one. Let us solve some problems, right, from the area that we have covered till now, and then immediately we will enter into phase 2. Clear? That will be the better approach in my point of view, right? Let us solve some of the examples, that the questions I already collected. I think TRB questions also I took in this one. You can also find TRB question is available in your website, right? Just you can Google it, right? Download it and you can try. TNAB questions are not available. That is not possible. You cannot see. You can just try, right? You numerical theoretical questions you solve panni parunga. Questions will be very simple only. Okay guys, let me continue. Just write down the question. For the logic circuit shown in the figure, right? So please write down the question. Let me write it on the board. For the logic circuit, for the logic circuit, for the logic circuit shown in figure, for the logic circuit shown in the figure, for the logic circuit shown in the figure, the output Y is equal to, the output Y is equal to, right? Anyway, the given diagram is, first let us draw the diagram. Please wait few minutes, because I have to complete the diagram. If I make any mistakes, then that will spoil your notes. So first I will complete the diagram, then I am requesting you to draw the diagram. Yeah. Yeah. Now you can draw the circuit that is the given A, B, C, right? Now what is the question? For the logic circuit, right? For the logic circuit shown in the figure, the output Y is equal to, right? Anyway, first I'm let me write down the options. Option A is given as A, B, C whole bar. Option B is given as A bar plus B bar plus C bar. Option C is given as AB bar plus BC bar plus A bar plus C bar. Option D they said none. இங்கே கொடுத்துருக்க எதுவுமே கரெக்ட் இல்லை அப்படின்னு சொல்லியிருக்காங்க. செக் பண்ணி பார்க்கலாமே, நமக்கும் தெரியாது இல்லையா? Let us proceed further. See what type of gate it is. We all know this is NAND gate. Yes, this is also NAND gate. Exactly, this is also NAND gate. Of course, this is also NAND gate. This is OR gate. Yes, here we have OR gate. And we know the corresponding operations. Let's check. See, here we are passing variable B is entering here, A is entering here. But NAND gate ling output enna varum? A dot B whole bar. That is the output of the NAND gate. Similarly, B is coming here, C is also coming here. Output of the NAND gate B dot C whole bar. Now, what your OR gate will do? OR gate will add these two things such that output of the OR gate will become A dot B whole bar plus B dot C whole bar, right? So let me consider the OR gate output is X. Right, now let us consider its output is, let us see, inga enna varudhu paakalama. A is coming here, simply here also A, here also A, such that you are getting A dot A whole bar which is equal to A bar only, because A dot A. Similarly, C is coming here, C dot C will become, that is C dot C whole bar anyway which is equal to C bar only, right? Now this OR gate once again add these three variables such that A bar is coming, X is coming here, C bar is coming, so your output will become A bar plus X plus C bar. But we all know what is the value of X. That portion is visible. Yes, that is visible. X oda value enanga? X is the addition of A dot B whole bar plus B dot C whole bar. So it can be written as A dot B whole bar plus B dot C whole bar plus here it is going to be C bar. Do you have any option like this? A bar plus C bar plus A dot B whole bar plus B dot C whole bar. See how easy your questions are, right? Let us take the next one. Write down. The output of a logic one, right? Please wait. I will write the question on the board such that you will be able to give the answer easily. Okay, let me write down the question first. The output of a logic gate is 1. The output of a logic gate is 1. The output of a logic gate is 1 when all its inputs are at logic 0. When all its inputs, when all its inputs are at logic 0, when all its inputs are at a logic 0, right? Now the conclusion, logic 0, then the gate is either, right? Then the gate is either, let us write the answers, right? They are given 4 options. Option A, a AND gate or an XOR gate, sorry, a NAND gate, a NAND gate or XOR. They are given 4 options, right? It might be NAND or XOR, just I am writing the answers simply. Option B, they said NOR or XNOR. It might be NOR gate or it might be X NOR gate, or it might be X NOR gate. Option C, they said. See, you might started posting your answers. Why are you waiting, right? You just read the question and tell me the answer. I'm expecting your answers in the comment section. Do it. In option D, AND or XOR gate. AND or XOR, yes, of course, that is correct. Okay guys, let me write. Given options la enna gates irukka? XOR irukku, XNOR irukku, AND irukku, OR irukku, NAND irukku, NOR irukku, ellame irukku போல இல்ல. Let's write. என்ன ஆகுதுன்னு பார்த்துக்கலாமே. Fine. இப்போ நமக்கு ஆன்சர் தெரியும் நினைக்கிறேன். See, the output of the logic gate is 1 when all its inputs are 0. இந்த மாதிரி ஒரு பாசிபிலிட்டி கண்டிப்பா XNORல வந்திருக்கும். கரெக்ட்டா? இப்போ XNOR கேட்டுக்கு நீங்க அவுட்புட் எழுதுங்களேன். XNOR கேட்டுக்கு நம்ம லாஜிக்கல் எக்ஸ்பிரஷன் எப்படி எழுதிருப்போம் அப்படின்னா, ஃபார் அன் எக்ஸாம்பிள் AB அவுட்புட் இஸ் Y. What is output? 0 0 0 1 1 0 1 1 for XNOR. 0 0 output is 1, for 1 1 output is 1, rest of people I am getting 0. That is the logical output of XNOR gate. Of course, that is correct, right? அப்ப XNOR gate la என்ன சொல்லிருக்காங்க பாருங்க, the output of the logic gate is 1 when all its inputs are at logic 0. When all its inputs are at logic 0, its corresponding output is 1. So there will be a possibility, right? XNOR la நம்ம expect பண்ணலாம். Next, shall we expect the same thing in NAND gate, right? NAND oda output என்னங்க? Let's see what happened. NAND gate எடுத்துக்கிட்டீங்க அப்படின்னா, once again let us consider AB corresponding output is Y, such that 0 0 0 1 1 0 1 1. In NAND gate for 0 0 we are getting 1 1 1, here we are getting 0. Correct? This is the output expression of NAND gate. So the possibilities, once again according to the given data, output is going to be 1 when all its inputs are going to be 0. Do you all agree with me? How many of you had posted your answer? Right? So the correct answer is what? Option A, right? NOR gate க்கு என்னங்க வரும்? See, the thing is, see, sorry, option A இல்ல guys, please. This is XOR they made, right? This is not XOR. XNOR is working now, and NAND is correct, but XOR won't give you, right? So A is wrong. XNOR is correct. NOR gate check பண்ணி பார்த்துக்கலாமா? NOR gate க்கு என்னங்க வரும்? So let me write. For NOR gate I don't have space. எங்க எழுதுறது? ஓகே, உங்களுக்கு தான் இப்போ தெரியும்ல, XNOR க்கு பாசிபிலிட்டி இருக்கு, NAND gate இருக்கு. இப்போ நம்ம NOR gate check பண்ணி பார்த்துடலாமா? So let me rub this one. Let me write for NOR gate. NOR gate ka output enna? 0 0. Let us consider two variables AB. Output is Y. 0 1 1 0 1 1. I think for NOR gate this is 1. Rest of all people are 0. I hope I am correct. So this is also correct only. For all input logic as 0, output logic is going to be 1. Yes. For NOR gate also we can expect the same thing, right? So NAND gate is correct. Perfect answer. NOR gate also correct. XNOR also correct, but XOR is wrong, right? And see that R is wrong, obviously. XNOR is correct. XNOR is correct, but AND is wrong, right? XOR, that is also wrong. So in which option all are correct? The one only option is option B. So the correct answer is option B. Okay, let us take the next one. Slowly try, right? Trust me, you will realize how easy your digital circuits are. Is there any things to memorize? No. Out of 10 you can get exactly 10 marks, right? Without any negatives. Digital is that much easy, right? It's a really scoring subject and it's quite interesting too. Let's take the next one. The output of the circuit shown in the figure is equal to. Question is, the output of the circuit shown in the output of the circuit shown in the figure is equal to. The output of the circuit shown in the figure is equal to. The output of the circuit shown in the figure is equal to what? So let's see. Diagram. First I have to draw the diagram. Please wait. let's the given it is A B bar both are A B bar only, and they had given 4 options. They have given 4. A is 0, option B is 1, option C is A bar B plus A B bar. Do it by yourself, please don't wait for my answer. That's your task, right? Bringing the answer is your responsibility. A B whole bar. See, they are writing the answer like this. What is this? A dot B whole bar dot B dot B whole, this, see there, either anything only one or three, instead of considering these two functions, we can consider only one function. That is enough, right? But they have written the option like this. Fine, that's not a problem for us. Let's continue our journey. But output, we all know this is what? This is XNOR gate. Yes or no? Its output is what? A is going to be XNORed with the B bar. Similarly, A is going to be XNORed with the B bar. Right? Again, output. Let me treat this one as X, and let us treat this one as C. Let me do this one as P and this one as Q, such that output is going to be what? P XNORed with the Q. Exactly, that is correct. Let's start our journey with this. Actually, it can be written as P bar Q bar plus PQ. Correct? Exactly, that is correct. That is the output of XNOR. Similarly, Q can be written as, guys, இது எப்படி எழுதுவீங்க ப்ளீஸ் A XNOR B bar, இது எப்படி எழுதுவீங்க? That is A bar dot B, already we have bar, we have to take whole bar plus A B bar, right? So such that it can be written as A bar B plus A B bar. Correct? Exactly, that is correct. Same thing you can observe here also, because see there we are observing both are same only, so P is equal to what, right? So P is also equal to, we can write A bar B plus what we got actually, A B bar. Yes, A B bar only, because both will give you the same output, right? Such that first of all, one thing I can write like this: P and Q are equal. Direct நீங்க எழுதிக்கலாமா? P க்கு பதிலா Q போட்டீங்கன்னா Q bar dot Q bar will become Q bar plus, see, answer is over. I'm wasting your time. I'm really sorry. See there, that is become Q bar. That is P and Q are equal. Now that is Q plus Q bar equal to 1. Answer is B. That is not required, right? Sorry, forgive me, I did not notice that one. Since both gates are having same input now, so you are going to get same output, right? If you are giving same input, see there, in the same output varudha, and the same outputs will going to be the input of what? XNOR gate. XNOR க்கு நீங்க பாஸ் பண்ற இன்புட் சேமா இருந்தா output is 1. யார் வேணாலும் பாஸ் பண்ணிக்கோங்க. பாஸ் பண்ற இன்புட் சேமா இருந்தா output is 1, right? You can pass any combinations. I don't want to know that one, right? இங்க நீங்க பாஸ் பண்றது அவுட்புட்டும் இங்க இருந்து பாஸ் பண்ற அவுட்புட்டும் சேம் தானே? சேம் இன்புட், right? So input sideல சேம் வேல்யூ கொடுத்தீங்க அப்படினா it might be 0 ஆ இருக்கலாம், it might be 1 ஆ இருக்கலாம், it might be A ஆ இருக்கலாம், it might be B ஆ இருக்கலாம், like இந்த மாதிரி ஒரு other combination இருக்கலாம், but same input na output is 1. I am getting 1, right? So that is waste of time. That is what I have been told you. We should let our brain to work. Yeah. Let's take the next one. See, this thing's not required. Please forgive me. Don't waste your time. Directly I can say both are equal. So P and Q are equal, output is 1. It's over. Next one. The output of the logic gate in the figure is, next one is the output of the logic gate. The output of the logic gate in the figure. The output of the logic gate in the figure is, right? So let me take the diagram first. Please post your answers. Don't wait for me. I'm repeating. Bringing the answer is your responsibility. Once you understand, then you just proceed, right? Now I know you all are understanding these things, right? In digital, nothing is there to understand. Just you have to your ஏதாச்சும் இதில் கான்செப்ட் நம்ம முன்னாடி படிச்சிருக்கோம், அதை அப்ளை பண்ணோம், அப்படி ஏதாவது மைண்டில் தோணுன்னு நினைக்கிறீங்களா? எதுவுமே இருக்காது. நீங்கள் பேசிக் லேர்ன் பண்ணது அது ஆட்டோமேட்டிக்காக உங்களுக்கு புரிஞ்சிருக்கும், நீங்கள் அப்படியே அப்ளை பண்ண வேண்டியதான். இதை வச்சு நீ மெமரைஸ் பண்ணுறதுக்குலாம் இங்கே வேலையே இல்லை, ரைட்? யூ நோ நீட் டு டேக் ஷார்ட் நோட்ஸ். தட்ஸ் வாட் மை இன்டென்ஷன், ரைட்? ஸோ லெட்ஸ் டேக். என்னங்க கேட்டிருக்காங்க? அவுட்புட்டா? ஓகே, ஃபைன். இது என்னது ஆக்சுவலாக? வாட் இஸ் திஸ்? எக்ஸ். This is what? Anyway, this is 0 first. Let me conclude. This is what? This is X NOR gate, right? X NOR. What is the output? For X NOR gate, right? I am giving A 0. Output என்ன வரும்? A X NOR of, that is X NOR with the 0. இது நீங்கள் எப்படி எழுதுவீங்க? Actually, it can be written as A bar dot 0 bar plus A dot 0, such that 0 bar will become 1. 1 into A bar will become A bar only, plus A dot 0 will become 0. A bar plus 0 will become A bar. What is the answer? Option D, right? Is there anyone of you posted the answer? No. Fine. Let's take the next one. 1 second. Yeah, the logical expression of, see, that is very simple question. Anyway, in your examination you can expect this type of chilly questions only, right? So the question is the logical expression of the logical expression of y is equal to a plus, wait a minute, let me check it myself, right? A dot b whole bar, right? The logical expression of this one. They had given 4 options. In option A they said that is equal to AB. Option B they said AB whole bar, AB whole bar. In option C they said A bar plus B. In option D they told A plus B. They told A plus B. Fine, right? So let us look at the solution for this one. Someone of you had given the answer, right? I'm really feeling very happy. Let's take this one. Actually, we cannot directly apply. First of all, I have to break this person. A dot b whole bar. Shall we apply De Morgan's? It's over. A plus, according to De Morgan's law, it can be written as A bar plus B bar. Yes. What is the answer here? See there, A plus A bar will become 1, right? So 1 plus B bar, which is equal to 1, you know. What's wrong with them? If it is like this, then A plus A, then it will become A plus B bar. That is not possible here. That is also wrong. Second thing, A plus A bar dot B, na? A plus A bar, which is equal to, no, actually A plus A will become A into A plus B bar, which is equal to what? A plus A, that is A only. Guys, please wait a minute. A plus B bar, such that A dot A will become A plus, no, again you are getting the same expression, right? So that is wrong. Then that is not possible. If it is bar, then A plus A bar will become 1, such that we are going to get A plus B bar. That is correct. See, we are not getting the option for the given question. They had given A plus AB whole bar only. So A dot B whole bar can be written as A bar plus B bar. A plus A bar, which is please 1 second, wait a minute, let me check it myself. Whether it is correct or not. Guys, I don't know. I think they made some mistake, right? Let's see other possibilities, because answer is not available. Let me check it myself. For this one, this is the answer. Okay, you can check. You can take for y is equal to A plus A dot B whole bar This is the answer. 1 is the answer. You can fix it, right? Anyway, let us try to bring the answer. I think they made some mistake in the question, right? Let me fix it. If it is a bar, if it is a bar dot b, then what will be the answer? If it is a bar dot b, then it is become, according to, see, if it is a bar dot b, then shall we apply distribution? It is become a plus a bar, and it is become a plus b. That is correct, right? And second thing is, so a plus a bar is equal to 1 na? So 1 into a plus b, it is equal to what? A plus b. That is one way. Suppose if it is a plus a b bar, then it is become a plus a into what? A plus b bar. So a plus a will become a only, a into a plus b bar. Do you have any option like this? No, this is wrong actually. But if I will go with this one, I got option D, right? I am getting option D. So I think in this question, that is a bar dot b, right? Then you are getting option D. For a plus b, sorry, a dot b whole bar, your answer is 1, right? So this is another one. For the question, this is the answer. Okay, please correct it, right? I think they made mistake. No problem. Let's continue with the next one. For the logic circuit shown in the figure, the required input conditions to make the output as 1, right? So let's proceed. Let me rub this one. Yeah, let us take the next question. First, write down the question. For the logic circuit shown in the figure, given it is for the logic circuit shown in figure, for the logic circuit shown in figure, for the logic circuit shown in figure, the required input conditions, the required input conditions, the required input conditions a comma b comma c, the required input conditions a comma b comma c to make the output equal to 1, to make the output x equal to 1 is, and they are given the diagram. Yeah, let me draw the diagram first. Option A, 1 comma 0 comma 1. Please do it by yourself, don't wait for me, right? Because you know the procedures, there are no things to understand. I'm repeating, digital is easy, very very easy. It's not the word, right? I'm just proving it. You can trust me. Try, bring the answer. என்னங்க வரணும், அவுட்புட் வந்து 1 அவங்க சொல்லிட்டாங்க. கவனிங்க, இங்கே தி பியூட்டியஸ்ட் திங் இஸ், சின்ஸ் இன் தி அவுட்புட் வி ஹாவ் அ அண்டிகேட். அண்டிகேட்டில் எப்போங்க அவுட்புட் 1 வரும்? அண்டிகேட் அவுட்புட் எப்போ 1 வரும்னா, வென் ஆல் யுவர் இன்புட்ஸ் ஆர் கோயிங் டு பி 1, கரெக்டா? That is the only case when we are getting 1 in case of AND-gate, such that here also we are going to get 1, here also we are going to get 1. Getting me? Yes. Now coming back, and C is going to be 1. கரெக்டா? இந்த 1 அப்படியே இங்கே வந்துடும், இந்த 1 இங்கே வந்திருக்கு, இந்த 1 இங்கே வந்திருக்கு. Since it is XOR gate, XOR கேட்டுக்கு அவுட்புட் எப்போ 1 வரும்? இன்புட் வந்து 1 0 இருக்கணும், இல்லை 0 1 இருக்கணும். இது ரெண்டுத்தில் ஒரு பாசிபிலிட்டிஸில் மட்டும்தான் XOR கேட் அவுட்புட் 1 இருக்கணும். கரெக்டா? ஆல்ரெடி இதில் ஒரு இன்புட்டோட வேல்யூ நமக்கு தெரிஞ்சிருச்சு 1ன்ட்டு. கண்டிப்பாக இது 0 தான் இருந்திருக்கணும். வை? பிகாஸ் 1 0 இல்லை 0 1 அந்த காம்பினேஷனில் மட்டும்தான் அவுட்புட் 1 வரும். பட் தி மேண்டேட்டரி கண்டிஷன் ஆல்ரெடி ஐ எம் கெட்டிங் தட் இஸ் 1. இங்கே 1னா கண்டிப்பாக இது 0 இருக்கணும். தென் only you will get 1 0 காம்போ. ஸோ அவுட்புட் இஸ் கோயிங் டு பி 1. B is 0 அப்படின்னா A கண்டிப்பாக என்ன வந்திருக்கும்? இங்கே XOR இருக்குல்ல, இதுவும் XOR. அவுட்புட் 1 வரணும் அப்படின்னா இங்கே 0னா it is mandatorily 1 because 1 0 இல்லை 0 1 மட்டும்தான் அவுட்புட் will become 1, right? Such that A is 1, B is 0, C is 1. Do you have any option like that? Yes. Option A is the correct answer because A is 1, B is 0, C is 1. Let me repeat once again. Listen, in this question it was clearly given output is going to be 1. AND gate output எப்போ 1 வரும்? When all your inputs are going to be 1, that is the only case when output is going to be 1. அப்போ இங்கே என்ன வந்திருக்கு? இந்த லைனில் 1 வரணும், இந்த லைன்லேயும் 1 தான் வரணும், இந்த லைன்லேயும் 1 தான் வரணும். And the simplest things to understand is this is XOR gate. XOR கேட்டில் அவுட்புட்டில் எப்போ 1 வரும் அப்படின்னா when we have different inputs. இன்புட் வந்து இங்கே 1 0 இருந்தது அப்படின்னா இங்கே ஆல்ரெடி 1 இருக்கு, இந்த 1 அப்படியே இங்கே வந்திருக்கும், இங்கே 1 இருக்கு. இப்போ இங்கே அவுட்புட் 1 வரனா இது 0வாக தான் இருந்தாகணும். தென் only 1 0 will give you 1. இங்கே நான் 1 போட்டேன்னா 1 1 அவுட்புட் இஸ் 0 ஃபார் XOR கேட். பட் அவுட்புட் என்ன வரணும்? 1 வரணும். ஸோ மேண்டிட்டர்லி இட் will be 0. இது 0னா இங்கேயும் 0 தானே, இது 0னா இது என்ன வரும்? கண்டிப்பாக சேம் as இங்கே 1 வரனா இது 1 இருக்கணும், ரைட்? ஸோ such that 1 0 1 will give you 1, right? So the correct answer is what? Option A, right? Yes. Some of you had posted the answer. Let us take the next one. So let me rub this one. See, the next one is for the logic circuit shown in the figure, the simplified Boolean expression, right? Okay guys, you let me draw the diagram first and then I will explain. Please be patient. Don't draw the diagram because I will do some corrections. That's all. Let us take ABC. Can you please bring the answer? Let me write. Just there, you are requested to find out the output expression. Option A, they said that is A plus B plus C. Option B, they said A. Option C, they said B. In option D, they said 0, I think. Yes, option D, they said 0. Right? Shall we proceed? Yes. Let's see what happened. See, this is AND gate. Its output is what? A dot B whole bar. Exactly. And see there, B is coming here. here this bubble denotes there is an inverter, right? Inverter na not gate. அது என்னங்க பண்ணும், b உள்ள enter ஆகும்போதே b bar மாத்திரும். அப்ப output என்ன வரும்? See, this is the NAND gate. It will perform its operation separately, and with the NAND gate we are also considering one inverter with b input, right? So first in the bubble cross பண்ணும்போதுனா b என்னவா transform ஆயிடும்னா b bar transform ஆயிடும், right? அப்ப outputல இங்க என்ன வரும், such that in the input, right? So இந்த இடத்துல எனக்கு a dot b bar enter ஆகுது dot, right? இதுல யார் enter ஆகுற அப்படினா b bar enter ஆகுது. We should take whole bar. Guys listen, NAND gate என்ன பண்ணும், இன்புட்ல வர வேரியபிள்ஸ்க்கு whole bar எடுக்கும். இன்புட்ல இங்க என்ன வருது, a dot b whole bar. இங்க யார் enter ஆகுறா, b bar. So a dot b whole bar dot b bar whole bar. Why it is taking whole bar? Its input is here. இங்க இருந்து வர input dot, இங்க இருந்து வர input whole bar. That is the output of NAND gate. Repeat. இப்போ இங்க என்ன வரும், see that this b is coming here, same b is going here, but here it will be transformed as once again b bar convert ஆகுது, right? அதே மாதிரி இங்க outputல வந்திருக்க variable, right? So இதோட output, right? So let me consider this one is going to be ab bar dot b bar whole bar. This is the input, correct? அதே மாதிரி இங்க யார் வருவா, again b bar. We should take whole bar. I am repeating once again, guys listen. இதுல போற input b bar, இதல enter ஆகிற input this one. So this dot this whole bar, that is the output of NAND gate. What about NOR gate? NOR gate la this input will enter here, right? இதுக்குள்ள யார் enter ஆகுறா, c bar, such that its output will become, it will become a dot b bar dot b bar whole bar. இது இங்க enter ஆகுது plus c bar also entering. But NOR gate என்னங்க பண்ணும், NOR gate என்ன பண்ணுனா இங்க இருந்து வர வேல்யூ இதுல வர வேல்யூஸ் ஆட் பண்ணிட்டு and then it will take whole bar. That is NOR gate output. Yes. Now before passing these two people into the next NOR gate, let us reduce this function as much as possible in order to get the clear idea. First let me reduce this one, right? இப்போ இத reduce பண்ணிக்கலாமா, இது எப்படி reduce பண்ணலாம், guys listen. So anyway here I have a bar. இங்க first ஒண்ணு எக்ஸ்பிரஸ் பண்ணலாம். இந்த a dot b whole bar நம்ம எப்படி எழுதிக்கலாம் அப்படினா it can be written as a bar plus b bar according to De Morgan's law. அதுக்கப்புறம் இதை உள்ள மல்டிபிள் பண்ணிக்கலாம். இவங்க ரெண்டு பேரையும் மல்டிபிள் பண்ணீங்க அப்படின்னா a bar dot b bar, right? So இவங்க ரெண்டு பேரும் மல்டிபிள் see a bar dot b bar வரும் plus b bar dot b bar will become b bar such that this whole term can be expressed as, right? So அங்க என்ன வரும் அப்படின்னா a bar dot b bar வரும் plus you are getting b bar dot b bar will become single b bar only, right? Such that இது நீங்க எப்படி எழுதலாம், so it can be okay. It can be further written as a bar plus b bar, that is correct. Wait a minute, into b bar plus b bar, that is will become once again, yes, we are getting same, that is correct. So we can write like this, yes. So but we are having what, whole bar. இப்படி எழுதுனதுக்கு அப்புறம் we have to take இந்த பர்சனை மட்டும் நான் ரெடியூஸ் பண்ணிட்டு இருக்கேன், right? whole bar. இதை நீங்க திரும்ப எழுதலாம் a dot b whole bar, right? Or else see இதை நீங்க see do one thing, please wait a minute. In the bracket we can take a bar வெளில எடுத்துட்டீங்கன்னா, sorry b bar வெளில எடுத்துட்டீங்கன்னா இங்க என்னங்க வரும், very simply we can write b bar வெளில எடுத்துட்டீங்கன்னா a bar plus 1 ன்னு வரும், கரெக்ட்டா? a bar plus 1 such that anything plus 1 is 1 in digital. So here we have only b bar. A bar plus 1 will become what? See, we can take b bar from outside now. From these two people we can take b bar outside. So a bar plus 1 will become 1. So 1 dot b bar become b bar. B bar whole bar will become b only. Such that what I got here, this whole expression can be replaced by b. Finally I got b dot b bar 0. We all know inga b bar thananga irukku, so b dot b bar will be 0, right? So this whole value is going to be 0. 0 bar equal to 1. So I am getting 1 here. Enga at this point we are getting 1. Let's see what happened here, right? So இப்போ இங்க நீங்க 1 பாஸ் பண்றீங்க அப்படினா, sorry, if you are reducing this function, right? So இத நான் ரெடியூஸ் பண்றதுக்கு பதிலா let me tell you one small thing. Once again இங்க NOR gate தான இருக்கு. NOR gate usually என்ன பண்ணும், see there, this is NOR gate. For an example இங்க 1 இருக்கு, இங்க x இருக்கு. NOR gate outputல என்ன வரும், output of the NOR gate is going to be 1 plus x whole bar ன்னு வரும், கரெக்ட்டா? But we know in digital 1 plus anything will be 1 only. 1 plus anything will be 1 only. So 1 bar will become 0. Any mistake? No. I am not reducing this function, but I am telling இங்க எனக்கு 1 இருக்குங்க. 1 plus anything will be 1 only in digital. So 1 plus anything இத பத்தி எனக்கு வரி பண்ண தேவையில்லை. இது என்னன்னா இருந்துட்டு போகுது, எனக்கு தேவையில்லைன்ற நானு. So 1 plus anything 1 only, right? So 1 plus anything 1 அப்படினா 1 whole bar will become 0. So the answer is what? Do you have any option? Yes. Did anyone posted your answer? 0. Yes. So we are getting 0 in the output side, right? This, see how easy your questions are, right? Just you have to learn how to reduce these functions. That's enough. Okay. Let's take the next one. So let me rub this one. Okay, guys, the next question is the number of distinct Boolean expressions of 4 variable is. The question is the number of distinct Boolean expression for 4 variables. Distinct Boolean expression for 4 variables. The number of distinct Boolean expression for 4 variables. Can anyone please post the answer? I'm just waiting for your answer because it's pretty simple. We all know how to bring the answer for this one. Option B, they said 256. Option C, 1024. Option D, they said 65536. Did anyone got the answer? Let's see. Guys, listen. This is already we saw the formula. The number of distinct Boolean expression, right, for 4 variables. Boolean expressions, the number of distinct Boolean expressions for 4 variables. What is the answer? 2 power n. Correct? Right? So that is the formula already we saw. Right? We have seen for n variable, I have written the answer. The number of distinct, that is Boolean expression, right, or Boolean functions can be written as 2 power n. Right? So did anyone posted your answer? Right? Let's see. That is 2 power n is what? 4. Right? N equal to 4. They said 4 variables such that 2 power 4 is 16 na? Yes. Right? 2 power 16 FDL. So let me write like this. 2 power 10 dot 2 power 16 LDklama. That could be much better for me. Right? And we all know 2 power 10 is what? 1024 into 2 power 6 is what? 2 power 3 is 8. 2 power 3 is 8. 8 into 8 is 64, I think. Listen. நமக்கு எனக்கு ஆன்சர் தெரியாது, ஆனால் எனக்கு ஒரு விஷயம் தெரியும். கண்டிப்பாக இது 256ஓ 16ஓ இல்லை 1024ஓ கிடையாது. பிகாஸ் ஆல்ரெடி 1024 இங்கே வந்திருக்கு. அது கூட நான் 64 மல்டிபிள் பண்ணோம். கண்டிப்பாக இது மட்டும் தான் ஆன்சராக இருக்கும். எனக்கு இது மல்டிபிள் பண்ணால் என்ன வரும்னு தெரியாது. பட் ஐ எம் கெட்டிங் ரைட். தட்ஸ் ஆல். ஸோ ஆப்ஷன் டி. யா, லெட்ஸ் டேக் தி நெக்ஸ்ட் ஒன். As the given is, if the input to the digital circuit consisting of 20 XOR gates, right? If the input to the digital circuit, if the input to the digital circuit consisting of a cascade of 20 XOR gate, cascade of 20 XOR gates in X. See, that is not in, actually they made mistake, that is printing mistake, is X. Okay, let me continue. The output of Y is equal to, the output of Y is equal to dash, right? First let us draw the diagram. Actually the given diagram is they had given a diagram. Again they have drawn one more diagram. It will be continuous. Now similarly they told this is going to be like this, and like this. They are connecting this all together and it will be continuous, totally they are considering 20 XOR gates, right? They are considering 20 XOR gate. So this is going to be output Y, and in the input side they told this is X and this is 1, right? That is 1, yes, yeah, that is correct, right? So let me write down the options for you all. Options on the 0 1 X bar X, right? They said option A 0, option B they said 1, option C they said X, option D they said X bar, right? Can you please tell me the answer now? Yeah, the answer that I am expecting is from your side. See, okay, let's see. Let me prove it. இங்கே 1 இருக்காங்க, இங்கே X இருக்கா, இது என்ன கேட்டா? இது XOR கேட், கரெக்டா? XOR கேட்டில் இப்போ இந்த இடத்துல அவுட்புட் என்ன வரும்? கரெக்டாக இந்த இடத்துல 1 ப்ளஸ் தட் இஸ் 1 XOR with X, கரெக்டா? அப்போ அவுட்புட் என்ன வரும்? It is going to be 1 bar X plus X bar 1, correct? That is A bar B plus A B bar, that is the output of XOR gate. So that is going to be what? 1 bar 0, 0 into X 0, right? X bar into 1, X bar only, such that its output is X bar. So conclusion is what? Here I am getting X bar, here I am getting X bar. Let's see again, இங்க என்ன வருது பாருங்க, X is coming, right? இங்க X, it is continuing up to last gate, we are getting X only. இப்போ second gateல first gate is X bar, here I am giving X. இப்போ again outputல என்னங்க வரும்? We are going to get X bar XORed with X, such that again if I will express this one, இது எப்படி எழுதுவீங்க? A dot B bar, A dot B is X, I have to take bar, plus B A dot B bar எடுத்தாச்சு. அடுத்தது A bar, ஆல்ரெடி A வந்து X bar, அதுக்கு நீங்கள் bar எடுக்கணும், டாட் B அப்படியே வச்சுக்கணும். இதுக்கு ஆன்சர் என்ன வரும்னு பார்க்கலாமா? See there, X bar dot X bar will become what? X bar, that is correct. Plus X double bar equal to X only, na? X dot X will be X only. So X plus X bar equal to what? Which is equal to 1. Am I correct? So X bar XORed with the X, which is equal to 1, right? So what is the conclusion here? Which is equal to 1. Guys, any of you did get the idea now? Just see there, first இங்க 1 கொடுத்திருக்காங்களா, இங்க X கொடுத்திருக்காங்க, odd number of gate. First gate வழியா கொடுத்தப்ப X bar வருது, திரும்பவும் second gate outputல 1 வருது, even number of gate. அப்ப third gateல திரும்பவும் அதே input வந்துச்சு பாருங்க, 1X, அதே 1X தான். திரும்ப அவுட்புட்ல என்ன வரும்? X bar. fourth gateல 1, again X bar 1, again X bar 1, again X bar 1, again X bar 1. Odd number of gate X bar, even number 1, odd number X bar, even number 1. நம்மகிட்ட என்ன கேட்டிருக்காங்க? 20th X bar. இது even odd, even. Output is 1. Suppose 21th gate in the X bar, again 22 1, 23 odd number X bar. So what is the answer? This is 1, because you are requested for even gate, right? Even number of gate. Odd number கொடுத்திருந்தாங்கன்னா your answer is X bar. I hope things are clear to you all. So the correct answer is what option? B, right? Okay, let's take the next one. The Boolean expression simplifies to, right? So let me rub this one. The Boolean expression wait a minute. Okay, they had given the expressions, right? Okay, anyway, let us complete this one. Simplifies, right? So the Boolean expressions simplifies to, right? So let me write, expression is X plus Y, right? Given it is X plus Y, X plus Y bar, X plus Y bar, plus X Y bar, X Y bar, plus X bar whole bar, plus X bar whole bar, right? And they are given 4 options. Option A, which is equal to X, option B, which is equal to Y, option C, which is equal to x dot y, option D, x plus y. Can anyone please try and bring the answer? Anyway, let me do it. That's my responsibility. You please try and post your answer. நம்ம ஆன்சர் பண்ணலாமா? Take this one. Just let's multiply. இப்போ இவங்க ரெண்டு பேரும் மல்டிப்ளை பண்ணால் என்ன வரும்? X is being multiplied with x plus x is also going to be multiplied with y bar plus y is going to be multiplied with x. Y is also going to be multiplied with y bar, right? Plus the second option, right? இங்கே என்ன இருக்கு? A dot b a plus b whole bar. According to De Morgan's law, this function can be, see, one second guys, first let us reduce this one, right? Let us take whole bar அப்படியே வச்சுக்கலாம். இது உள்ள இது எப்படி எழுதலாம்? Shall we apply distribution theorem? According to distribution theorem, this function can be written as x plus x bar plus y bar plus x bar. We can write like this. That is De Morgan, distribution theorem. That is a plus b dot c, right? So we can write like this. Yes. So in the next step, anyway, x dot x will become x plus x y bar, right? Let me reduce slowly. Don't be panic. Y plus x, okay, no problem. Y dot y bar, that is 0 plus, right? Let's see, x plus x bar will become 1, right? So in whole bar we have y bar plus x bar, right? Let's see in the next step, from these two people we can take x outside, then you will get 1 plus y bar, exactly, plus yx plus a dot b whole bar. According to De Morgan's theorem, it can be written as a bar plus b bar. A is y bar, b is x bar. De Morgan's law, we will have one more bar such that this double bar is getting cancelled out. See, 1 plus y bar, anything plus 1 is equal to 1 in digital, such that it will become x plus y into x plus y plus x. Now what is the conclusion here, guys? Listen, x plus x equal to x only plus yx, right? From these two you can take x outside, it will become 1 plus y. From these two person you can take y outside, yeah, y we can take, right? Please forgive me, I made mistake. We can take y outside such that it will become 1 plus x, such that it is equal to x plus y. Now what is the correct answer? Option D, right? Did any one of you got the answer? Someone told that is x. Did I made any mistake? Please correct me if I made any mistake, right? No problem. Wait a minute, I'm just looking for the next one. 1 second. Okay. Next one, again you are requested to find out the output. Wait, if I'll find any new question, then we will solve. Because same model, you can try it by yourself. I will give these things to you. Okay, fine. That's all. So this is how we are solving the problems with the help of basic logic gates. Okay, fine. So what is the next target? Now we should start the next topic, right? So we are getting close to 7:30, right? So here right now that is not possible, right? So let me do one thing. We will start tomorrow. So next what we have to do, we have to discuss about min terms, max terms, then we will start K-map, right? So immediately that's all. With this phase 2 will be completed. Then till now we are looking for, that is we are waiting for a beautiful chapter that is called combinational circuit. So if it is possible, probably tomorrow we will start, otherwise the day after tomorrow we will start, right? If you have any other doubts, you can ask in the group, right? So let's find out with this. Thank you all.